Alright guys, welcome to another video of Calculus 2. Here we go. So we have a question here that tells us find the third degree Taylor polynomial of this function, sine of x, that is centered at c equals 0. And by the way, this is literally the exact same thing as a Maclaurin series, okay? So I put Taylor series at c equals 0. I could have just said find the third degree Maclaurin polynomial of sine of x, but obviously that, I just want you to know that a Maclaurin series literally is just a Taylor series centered at c equals 0. But we're not going to find a Taylor series. We're going to find a Taylor polynomial. Okay, and we're finding a third degree of that. So first of all, let me just show you how this works. So our function is sine of x. So let me just write that out for you guys. We could say that the 0th derivative of sine of x is just sine of x. It's the original function there, sine x. Now let's find the first derivative of it. The derivative of sine is just cosine. Let's find the second derivative. So the second derivative of sine x, well, the derivative of cosine is just negative sine. And then we find our third derivative. So the derivative of negative sine is negative cosine. And that's it. We don't need to keep going, okay? We just need the third derivative all the way up to the third derivative because we're trying to find the third degree Taylor polynomial. Well, we just need three derivatives starting from obviously our original function. And then the next thing you do is that now you take these derivatives and you plug in whatever c is centered at. So it says here c equals 0. So that's what we're centered at here. So that's what we're going to plug into these derivatives. So what's f of 0? Well, obviously that's just sine of 0. And sine of 0, sine of 0 is 0. Now let's figure out f prime of 0, right? All we're doing is literally just taking whatever c is centered at, c equals 0, and just plugging that into the derivatives. That's all we had to do. So cosine of 0 equals, whoa, I messed up real bad. Sine of 0 is not 1, it's 0. Cosine of 0 is 1, okay. And then f double prime of 0, what's that going to be? F double prime of 0 is, well, negative sine of 0 is just 0. And then last but not least, we plug in 0 into our third derivative. So that's negative cosine of 0, which obviously is just negative 1, right? Cosine of 0 is 1. You already have a negative sign there. So that'll be negative 1. So here is our derivative values right here, right? Obviously, you could say this is like the 0th derivative, which is just the original function. So we got 0, 1, 0, and then negative 1. All right, so here's how we do this. So essentially what you do is that you basically you don't need to find a pattern when you do this. You can just leave it like the idea is that when it comes to these Taylor polynomials, all you're really doing is just kind of finding like you're basically using the I guess the formula, if you will, for a Taylor series, and just kind of just writing out however many terms we want here. So it's the third degree, so we're just going to write out 4 terms here, right? Obviously we're including the obviously original function. So here we go. The first thing we plug in is obviously sine the first value from f of x, right? So we plug in f of 0, and then we multiply that times x minus 1 raised to the, I should say x minus c, right? Yeah, not just 1, obviously it could be c. X to the 0, all divided by 0 factorial. And then, let me get that out of the way. All right, plus f prime of 0, not equals, I don't know why I'm writing this stuff. All right, times x minus c raised to the first power, all divided by 1 factorial. So notice how we keep progressing. Notice how the factorial is getting bigger. The power that this guy's being raised to is getting bigger. The derivative is getting bigger, so that's kind of what's going on here. F double prime of 0 times x minus c raised to the second power, all divided by 2 factorial. And last but not least, I think I can fit in here. F triple prime of 0 times x minus c raised to the third power. All that stuff is going to be divided by 3 factorial. Okay, so essentially what we're doing is that we're just taking the stuff that we just got. I'm going to plug in the derivatives. C is just going to be 0 there, but I wanted to write that out for you guys just so you can see where the I guess x minus 0 is coming from. It's coming from the question itself. So it gives that to us. And the idea is that c is just 0, so it's just x essentially. And the idea is that, well, we just basically plug in the stuff that's already here. So f of 0 is 0, so we just plug that in. And obviously 0 times, all this other stuff is just 0, right? 0 factorial is just 1, and then x minus c to the 0th power, well, that's just 1 as well. So 0 times 1 is just 0. All right, the next thing is that we plug in the same stuff into here. Well, we found out f prime of 0 is 1. This is just x raised to the first power, right? C is just 0. 1 factorial, well, so that's not going to do anything. So essentially what we're going to get is just x. Plus, okay. And then we have f double prime of 0, right? We have f double prime of 0 over here. Well, that's just 0. And of course, 0 times all this other stuff is just 0, right? Let me just write that out for you guys. Minus, the reason why I put minus there is because for our fourth term on our Taylor polynomial, the third derivative is actually going to give us a negative value here. Okay, so negative 1 times that. We have x cubed, and we have it divided by 3. So let me just write that out for you guys. So it's negative 1/3, essentially. And then you have x raised to the third power, right? We got 1/3 because, oh, actually, no, sorry. That's 3 factorial, so essentially that's going to be 3 times 2 times 1, which will obviously be 6. So it's 1/6, whatever. This is just negative 1. C is 0, so essentially you got x cubed. So if we just get rid of these zeros here, they're basically useless. Our Taylor polynomial, you can write it as this. You can write p with a little 3 on the bottom, which basically means your third degree Taylor polynomial. It's going to be x minus 1/6 times x cubed. And that, my friends, is your third degree Taylor polynomial of the function sine of x that's centered at c equals 1. So essentially all you're just going to get is stuff with, x's essentially. It's basically just following this formula starting from, the original function all the way up to how many derivatives that the question asked you for. The question asks you just for the third degree Taylor polynomial means that you go all the way up to the third derivative. Essentially, you just plug in the values for the formula, and that's it. We're good to go. That's our Taylor polynomial.